Welcome back to my channel. In this video, we are going to see exercise 3.4 Maths Matrices, chapter 3, class 12. Question which is given as 1, 3, 2, 7, which is 2 into 2 rows. First, we have to consider A is equal to IA. This is matrix A. So, A is 1, 3, 2, 7, which is equal to identity matrix is 1, 0, 0, 1 into A. First, we have to make this 2 as 0. Okay. So, we'll consider an expression R2 minus 2 times R1, which gives R2. Okay. First, if we see 2 minus 2 into 1 is 2 minus 2, which gives us 0. Yes. So, next one is R2 is 7 minus 2 into 3. 7 minus 2 3 is 6. 7 minus 6 is 1. Okay. So, and next is this row. 0 minus 2 into 1. So, it is minus 2. Next is 1 minus 2 into 0, we get. Now, this whole matrix changes into this. That is, first row remains as it is. And these two changes into 0, 7 into 1 and 0 into minus 2 and 1 into 1. Okay, now our intention is to change this 3 as 0. So, now we'll consider another expression which changes that particularly that 3 into 0. Okay, so the expression is 3 times R2 minus R1 gives us R1. Okay, now we'll apply. The second row here is 0. So 3 into 0 minus 1 is minus 1. For the second one it is 1. 3 into 1 minus 3. 3 minus 3 is 0. Now is 3 minus the row 1, row 2 is here is minus 2 minus 1. So minus 6 minus 1 is minus 7. And next here is 3 into row 2 is 1 minus 0. So 3 ones are 3. So this whole matrix changes into now the 1 became minus 1, 3 into 0, 0, 1. The second row remains as it is. And next 1 into minus 7 and 0 into 3 and here minus 2, 1 and A. So now the only one we have to change is this row 1 we have to divide by minus 1. So divide the whole row 1 by minus 1. If we divide that row by minus 1, we get 1, 0, 0, 1, which is equal to here minus and minus get cancelled. So we get 7, here minus 3, minus 2, 1 into A. So we can say this is the inverse of A. Okay. This is the fourth question which is given as 2, 3, 5 and 7. Okay. Let this be matrix A. For that, first we have to consider A is equal to minus A. That is 2, 3, 5, 7, which is equal to 1, 0, 0, 1 into A. Now we have to change A into I. That is A, the left hand side A into identity matrix. For that, first we'll consider this element and change that element as 0. Okay, so 2 times R2 minus 5 times R1 gives R2. Let's see whether this expression helps us to get 5 as 0. So 2 into R2 is 5 minus 5 into 2. So which is 10 minus 10, 0. Okay. So next is 7. 2 into 7 minus 5 into 3. Okay. 14 minus 15, which is minus 1. And next one. 2 into 0 minus 5 into 1, we get minus 5. Next one is 2 into 1 minus 5 into 0, we get as 2. Okay, now this whole matrix changes into 2, 3. The first row remains as it is 1, 0, A. Second row 5 changed into 0, 7 changed into minus 1 and 0 to minus 5 and 1 to 2. Okay, now is we have to change this 3 into 0. Okay, we'll consider an expression. So 3 times R2 plus R1 we get R1. So let's see, 3 times R2 is minus 1 plus R1 is 3. So minus 3 plus 3 is 0. So this element got changed into 0. Okay, next we'll check for this column. That is 3 into R2 is 0 plus 2. We get as 2. And the next one is 3 into minus 5 plus 1. Minus 15 plus 1 is 14. and the next one is 3 into 2 plus 0. So 6. Now this whole matrix changes into 2 as became 2 is as it is 2, and here is 0, 0 minus 1, which is equal to 14, 14, 6, 5, 2 into A. Okay, so now we have to divide the row 1 by 2 and divide the row 2 by minus 1. Okay, we have to divide the row 2 by minus 1. If we divide the row 1 and row 2, row 1 if we divide by 2, 2 by 2 is 1, 0 by 2 is 0. Okay, which is equal to 14 by 2 is, so here it is actually minus 14. Okay, so minus 14 by 2 is minus 7. 6 by 2 is 3 into A. So now 0 by minus 1 is 0. Minus 1 by minus 1 is 1. Minus 5 by minus 1 is minus 5. And 2 by minus 1, here it is minus 5, right? So it is plus 5. And 2 by minus 1 is minus 2. So the inverse of A is minus 1, 3 plus 5 minus 2.